In this lesson, we're going to look at how to do a sort using the bubble sort algorithm. And I've got an animation of the bubble sort algorithm running right now. The way the bubble sort algorithm works is it works through an array and swaps greater and lesser values. So notice we're at 8, 7, and we swap it with 7, 8. Here we have the combination 8, 2. We swap it to get 2, 8. Next, we're going to have 8, 4, and we're going to swap that to get 4, 8. So what we're doing is we're bubbling lesser values to the front of the array and greater values to the back of the array. So notice the 3 and the 5 swap here. Now the 1 and the 5 is going to swap. Now the 5 and the 6 are in order, so they won't swap. 6 and 7 are in order. The 7 and 2 are not, so the 2 and the 7 will swap positions. The 7 and the 4 will swap positions. And so notice how the 7 now is in its right place. Notice that when they're in the right place, they change to a black square. So now the 1 is in the right place. 3 and 5 are correct. 5 and 6 are correct. The 2 and the 6 will swap here. Now the 6 and the 4 will swap. And now we have 6, 7, 8 in the right position. We start over again. The 1 and the 3 are fine. The 3 and the 5 are fine. The 5 and the 2 are not, so we'll swap those. The 5 and the 4 are not, so we're going to swap those. Now we're just down to 1, 3, and 2. We really only have to make one more swap right here. So we make this swap. Now everything is in the correct position. So let's see how to implement the bubble sort algorithm. We're going to use the insertion sort program we used before as a base for our bubble sort. So let's copy that code. You'll see I've already done a little bit of work on that. And we're going to create Notepad bubblesort.java. Create a new file, paste in the old. Let me take that out. So what I'm going to do, and what I've already done actually, is I've commented out the code for the insertion sort. And what I'm going to do is I'm going to write a function this time for the bubble sort. So let's take a look at that. The bubble sort method will take an integer array as its parameter. The first thing we do is we determine the size of the array by getting the length. That will become a variable we're going to use in our for loops. And we're going to write nested for loops just like we did before. Our outer loop will start at 1. It'll run through the end of the array and increment by 1 each time. Our inner loop starts at 0, continues on while I is less than size minus pass, and increments by 1 each time. And here's where we do our comparison and then our potential swap. Array sub I is equal to array sub I plus 1. And array I plus 1 is assigned the value in temp right here. With that, we're finished, so we close everything out. It's a void function because arrays, of course, are reference objects, so we don't have to pass an array back and forth. Now let's go back and look at our main program. In our main program, we have the same code we have before. So we write our first loop to initialize our array with random values. Then we display our values right there. So where we had the insertion sort, which is this commented out code, we will put a call to bubble sort along with our array data. Save the file. Go back to our command prompt. Let's clear the screen. Compile. Now run. So we had 39, 61, 61, 48, 10, 18, 51, 66, 60, 72, and 10, 18, 39, 48, 51, 60, 261, 66, and 72. Let's run it again. I won't read them all out, but you can check to see that it is sorting, so you can see that it works. So the bubble sort is another very simple sorting algorithm to implement. But again, and we'll give the same warning that we give for all of these, they are very inefficient for large data sets. So use them only on small sets of data when you need to. And as I'll mention later, that you should really use library sorts anyway. But, these are possibilities for sorting that are easy to implement should you choose to implement your own. But with that, we're ready to wrap up this lesson and move to the next lesson where we're going to look at the first of the more sophisticated sorts that are useful for large data sets, and that's called the merge sort.